Do a couple of examples of testing a claim about two proportions. And I'm going to jump into an example that I'm cooked up. Here's an example with significance alpha equals 0.05. Test the claim. People see ghosts at a higher rate than UFOs if 123 of 460 people saw a ghost and 203 of 783 saw a UFO. Now, the first thing I'm going to do is label these proportions. Let P1 equal the ghost proportion, P2 equal the UFO proportion, and like all the other hypothesis tests, there's three steps: the setup, the calculator, and the conclusion. I'm going to go through all three of those. So for the setup, it says that the ghosts at a higher rate than the UFOs. So if the ghosts are at a higher rate than the P1, which represents the ghost, is more than P2, so the claim is P1 is more than P2. And once I get that going, I can use my setup chart, and I'm going to go to the more than row to get this set up. Now this is in terms of P, but notice the greater than there, the greater than. I'm going to go across to get the rest of this set up. So the opposite of the claim is that P1 is less than or equal to P2. And again, I'm reading across the chart. The null hypothesis is that P1 is equal to P2, which is not from the original claim. And the alternate hypothesis is P1 is greater than P2, which makes for a right tail test. Okay, so that's the setup, and I just read that off the more than row in the chart. Then on the calculator, I'm going to stat tests, and then I think it's number 6 is 2prop z-test. So I'm going to stat tests, and number 6 is 2prop z-test, and the x1 and n1 are the numbers from the first proportion, which is the ghosts. For the ghosts, it was 123 out of 460. The x2 and n2 are for the second proportion, the UFOs, which was 203 out of 783. Now, for this one, I want to match the form of the alternate hypothesis. The alternate hypothesis is greater than, so I'm going to arrow over to the greater than, hit enter to make sure it takes, and then when I hit calculate, I get the two important numbers here are the z and the p. The z was about 0.315 to 3 decimal places. This is what is called the test statistic. The homework will ask you for that. And then the all-important p-value, about 0.376. The p is 0.376. This is the p-value that we're going to use to compare with the significance of the test, 0.05, and draw our conclusion. So now we're ready to draw our conclusion. So step 3, the conclusion. So P is 0.376, and the significance of the test is 0.05. P is not less than alpha, which means we fail to reject H null. And going back to the setup, H null was not from the original claim. Fail to reject. H null not from original. And then I'm going to go to my conclusion chart. Look under the fail to reject and not from original. Fail to reject, not from original. There is not sufficient evidence to support the claim. Not sufficient evidence to support the claim. Okay, I'm going to do one more example of this. So here's another example with alpha equals 0.05. Test the claim. The proportion who've seen Bigfoot is the same as the proportion who've seen a UFO if 115 of 503 have seen Bigfoot and 125 of 429 have seen a UFO. Again, three stages: the setup, the calculator, the conclusion. So for the setup, first of all, I'm going to make a choice. I'm going to let P1 equal the Bigfoot proportion and P2 equal the UFO proportion. And now I'm going to go to the setup of this example. So number one, the setup. Well, what is it asking? It says that the two proportions are the same. And so that means that they're equal. And so I'm using the is part of the chart. I'm going to read across this row to get the setup. So the claim is that P1 and P2 are equal. The opposite, and again, I'm reading this off of this chart. The opposite is that P1 is not equal to P2. The null hypothesis is P1 is equal to P2, which is the same as original. This is from the original claim. And the alternate hypothesis, P1 is not equal to P2, which makes for what's called a two-tail test. There's the setup. On the calculator, I'm going to stat tests. Number 6 is 2-prop z-test. Stat tests 2-prop z-test. And again, the x1 and n1 is the proportion from P1, the Bigfoot. The Bigfoot was 115 out of 503. The X2 and N2 are the proportion from the UFOs, which is 125 out of 429. I'm going to match the form of the alternate hypothesis, which is not equal. So I'm going to get the not equal one highlighted and hit enter. And now when I calculate, I'll get the p-value and the test statistic. The test statistic is this negative, z is negative 2.18 to 2 decimal places. So z negative 2.18, the test statistic. And then the p-value is this 0.029 rounded to 3 decimal places. P equals 0.029. This is what's called the p-value that we're going to use to compare with the significance of the test to draw our conclusion. So step 3 is the conclusion. P is 0.029. Alpha was 0.05. This P is less than alpha. P is less than alpha, which means we reject the null hypothesis. And in the setup, the null hypothesis was from original claim. From original claim. So I'm going to look on my conclusion chart. Reject H null from original claim. Reject H null from original claim. There is sufficient evidence to reject the claim. There is sufficient evidence to reject the claim.